hello, you're welcome to my channel. Now in this video, we're going to solve the following inequalities. Alright, now the first one, we have a quadratic inequality, which is very obvious it is, and the second one, it's still a quadratic inequality, but it's being made of linear terms. Alright, but maybe in the process we will see that. Okay, so the first one, we have x squared minus 9, which is greater than 0. Okay, in fact, let's just start off with the first question. So we want to find the values of x such that this inequality is satisfied. Okay, that's for the two cases, but we're starting with the first one first. So which value of x, which number, right, can we plug in for x? Or which set of numbers can we plug in for x such that when we square it, we subtract 9 from it, the result will be greater than 0. Okay, for example, when we have 4 squared is 16, and 16 minus 9, this is 7, which is greater than 0. Alright, that is what we are talking about. Now, if we take 3 squared, we will have 9. 9 minus 9 is equal to 0. It is not greater than 0. Alright, so 3 is not going to be a good candidate for x. You understand that? So we are looking for the values of x, the real numbers, such that when we square them, okay, the square of it will be 9. Right? When you square them, you have 9. When you subtract 9 from it, the result should be greater than 0. It should not be equal to 0. So in this case, when you subtract 9, you have 0, and 0 is not greater than 0. So 3 is not going to be the value of x. Okay, but 3 is not the only one that fails. Every number less than 3 fails, 2 and so on. But that does not actually spell the truth, because every number less than -3 also works out. So, in fact, this is going to be more complicated if you want to consider it in a linear way, right? So let's look at it in a very nice way anyway. So we'd like to construct a kind of a line for x, okay, and then do some things. Alright, so with the way I would like to do it, the second question I will consider it in another video, right? The video following this one. But the first question, let's look at a graph. When we have a graph of x squared, alright, it goes like this. It's just a curve. Okay, it touches this point at the origin, and it moves on like that, right? That is how it looks like, x squared. Okay, so it just meets at the point 0, and it moves on like that, alright? It moves this way. Such that when we have, for example, -3 squared will take us to 9, right? And when we have +3 squared also takes us to 9. Every other thing greater than +3 will be greater than 9. And every other thing less than -3 will be greater than 9 when you square it. So this curve is a curve of x squared, right? So what I'm trying to illustrate here is that we are looking for which values are we going to square such that the result will be greater than 9. You know, from the inequality, when we have that x squared is greater than x squared minus 9 is greater than 0, this simply means that x squared will be greater than 9. That is when you add 9 in the both sides of the inequality. So that means that x squared should be greater than 9. Sorry. So which values of x will we take such that when you square them, the result will be greater than 9? So you see that when you square -3, the result is going to be equal to 9. 9 is not greater than 9. So -3 will not be taken. Alright? And when you see +3, when you square it, you still get 9. So +3 will not be taken. And in fact, every numbers in this interval, the square will not even be up to 9. So they will not be taken. The only interval we're going to take are the interval from -infinity to 3 and the interval from 3 to +infinity. If you square -4, you will have 16, which is greater than 9. Therefore, it satisfies the inequality. In fact, the result for this first one is that the interval in which x will belong such that that inequality will be satisfied is that x should belong to this interval from -infinity to -3, excluded that open bracket, okay, shows we don't include this interval, this salient point, this end point, all right? And we unite it with 3 to positive infinity. So when you look at such interval, this negative 3 is not included because it is an open interval. Suppose we had this, all right, closed at negative 3. This would be a closed interval, which means that negative 3 is one of them. So this is it, right? Using the graphical notation or using a graphical method for that. But this is the interval that will belong, right? But maybe let's look at this in a systematic way, right? But we'll still make use of a line like this. Okay, so suppose we have we have already that x squared minus 9 is greater than 0. Well, that means that x squared minus 9 should not be less than or equal to 0. So should not be less than or equal to 0. So we have to solve for the values of x such that x squared minus 9 must be greater than 0. So our idea, or the idea here, or what I would like to do, is to find the values of x that will not satisfy that inequality. That is, find the values of x such that x squared minus 9 will either be equal to 0 or will be less than 0. You know, if it is equal to 0, it does not satisfy. If it is less than 0, it does not satisfy. So, I will first of all talk of equality with 0, then I will talk of x squared minus 9 to be less than 0. Okay, so with value of x, we will plug here such that x squared minus 9 will be equal to 0. In fact, let's just solve this, okay? We will have that, this implies that x squared is equal to 9. This means that x is, if you take the square root of both sides, alright, square root of 9, that is square root of 9. But since we are solving for an unknown, we would like to put this down as positive and negative square root of 9, alright, which will give us positive and negative 3. Okay, so these are the values that we will plug in for x. It will satisfy this equation, x squared minus 9 equals to 0. So when x is negative 3, x squared minus 9 will be 0. When x is positive 3, x squared minus 9 will be 0. So that means that this point should not be taken because it does not satisfy the main question, right? Okay, so we look at positive 3 and negative 3. In fact, this is what I would like to do with those values. We draw a line, okay, that is the x-axis. We pick negative 3, we pick positive 3, we will do a testing. Great. So what we would like to do is pick a point from this from this last interval. We call it interval A. We pick a point from the middle interval, and we pick a point from the last interval, okay? Okay, so in this left interval, let's pick any number. For example, we pick negative 4. Plug it into the main question. So negative 4, if you square it, you have positive 16, alright? You subtract 9 from that, that will be positive 7. Is 7 greater than 0? Yes. That means this interval satisfies what you want. Which interval is that? That is from negative infinity, right? You are moving towards negative infinity to negative 3. But negative 3 is excluded because it will make it an equation, which we don't want. Okay. The next thing is to pick a point from this interval, negative 3 and 3. For example, if you pick 0, we plug in 0 to x, and we have x squared, that is 0 squared, which is still 0. 0 minus 9 is negative 9. Negative 9 is less than 0. So this interval does not satisfy what we want. Therefore, no number here will be taken. Alright? Again, this last interval from 3 to x, we can still choose 4 or 5. For example, 5. 5 squared is 25. 25 minus 9 is in fact 16. 16 is greater than 0. So this interval satisfies, right? So it's only this middleman that does not satisfy what you want. So we can put it down this way as a result, from negative infinity to negative 3, excluded, union from 3 to positive infinity. We can also put the result down as that x, okay, that the x values are in the set of real numbers, okay, except this interval from, except this closed interval from negative 3 to positive 3. So it includes every other number, okay, except, sorry. So we show that x is an element of the real numbers except this interval from -3 to +3. That means it is not -3. That is why I've actually used a closed bracket to show that -3 is excluded, +3 is excluded, and every other thing between them. Alright? But when you want to show where does x belong, it belongs here and belongs here. But x belongs to here, but does not belong to this minus. You know about the sets? When we use negative, it shows every other element that belongs to this first set except this second set. Okay? So this interval is more like it's just the set when we can't list them. Okay, so that is it. We can use this to represent it, or we can use this, but take note of this one. Very important. Okay. Thanks for watching.